All right. So welcome, everybody. I am Shalini, the National President for WICCI's Emerging Technologies Council and your host for the evening. And along with my team here, we welcome everybody who is present here today to join us on this very important talk. Now, data is today's oil. Now, organizations are they are fighting for the best data, for the for the most amount of data, so that they can work on the data, process it, and apply data analytics on it for the best interests of their organizations. Now, why is that important, and how do they do that? And how does data analytics influence the digital transformation for organizations, and why it's important? We will be deep diving into these important topics today. So please fasten your seatbelts. It's going to be a heavy talk, but we are going to try to simplify it in simple words so that everybody can relate to and understand it. We are very happy that Mr. Sunil Vattal has joined us today. He is a known name in the field of data analytics, and he'll be sharing his insights with us today. So keep your mics on silent. We will be taking the questions at the end of the talk. So please feel free to add your questions in the chat box, and we'll be taking them up in the end. Before I hand over the mic to Priya, we would like to first invite Nandana. She's our data scientist of WICCI Council, and she wants to share her thoughts on why this topic is important. And after that, she'll be handing over the proceedings to Priya. With that, thank you, Mr. Sunil Vattal, for doing this for us, and welcome everybody once again. And now with that, over to you, Nandana.
Has not joined.
Nandana's there. I could see her. Maybe her mic.
I think her system is under upgrade.
I can see Nandana Virar. Is that Nandana?
Yeah.
Yeah. Nandana, are you going to give us your thoughts, or we can, or maybe we'll do one thing. Priya, why don't you just start, explaining about WICCI and then introducing our speaker, and then we will take Nandana's thoughts at the end of the show?
Sure. No worries.
Okay. Yeah.
Okay. Welcome and good evening, everybody. WICCI, the Indian Chamber of Commerce and Industry, founded by Dr. Harbeen Arora. We are an NGO that fosters support, collaboration, empowerment among women. The aim is to encourage and support collaboration among women. There are many councils catering to different fields, and ours is a council for emerging technologies. We have National Council and State Council. Every state council also has their own president, vice president, and other council members. We welcome women working in IT and emerging technologies to take up positions in the national and state councils. To take up these open positions, please contact me or our team, and we will be happy to onboard you. I'm Priya Pinto, and I head events with National Council for WICCI. Though the membership is only for women, knowledge is meant for all. Hence, we host inclusive events. As ground rules, please keep your phone on silent. Keep a pen and paper handy to take notes. It is a pleasure to host everyone today, and we welcome our esteemed guest, Mr. Sunil Vattal, who is an engineering graduate from BITS Pilani, an MBA in finance, and also an MCA. Sunil has over 30 years of industry experience with Oracle Corporation, General Electric, Colt Telecom, and IBM. Sunil is currently working as a Joint Chief Technology Officer for Department of IT, Electronics and Communication for the Government of Haryana. Sunil has expertise in project management and in consulting globally across technologies, functional domains in various roles pertaining to delivery management, client relationships, skill management, data analytics, and strategic business planning. He also supports startups in advisory capacity by mentoring in areas of workforce development, coaching, and entrepreneurial strategy. Now let's welcome Sunil Vattal to take us through an engaging session on data analytics and digital transformation. Over to you.
Okay. Thank you, Priya. First of all, I would thank the organizers for inviting me for this session, and I look forward to a very good interactive session with all of you. Also, I appreciate the time spent by all the participants. I'll try to make the presentation brief and leave the last almost 15 minutes open, 15-20 minutes open for a question answer session. So I do have a presentation here. We'll walk through the slides. The basic agenda is that we're going to talk about data analytics and digital transformation. I would also want to share a few examples or cases as which happens in our everyday way of working. It happens around us. So Priya will be assisting me. She's projected the slides. So Priya, can you please go to the next slide? So yeah, when we talk about data, data is a very important concept. It's becoming a very important concept today. And as Shalini pointed out, it is the new oil. It's the oil of the current century. And basically, it gets classified into three components: raw data, and which gets processed and moves into information. So enterprises basically capture raw data and then process this into information. And this becomes, information in turn becomes one of the basic critical inputs for business decisions. Today, major business decisions are taken on the basis of this analysis, on the basis of the results of such analysis, and this gives an edge over competition. So basically, what are the important factors? How does it help us in our business development? And I'm looking at it from a business perspective, from a business development perspective, business growth perspective. So data and analytics helps us into cost reduction, time reduction. We also do process optimization, product developments and product optimizations, smarter decision making, and supports the strategic decisions. We see a lot of it happening in retail. If you look at the retail industry today, it helps us in decisions about what is the product mix that I need to store, what is the product mix that I need to display. Even the display shelves are optimized based on the data that we capture. And one of the essential things is in a financial market, it helps us in fraud detection and fraud prevention, which is a vast subject in itself. We could probably do a separate session on that. So if we look at data, and again, what has happened in the past decade or 2 decades, there has been a huge growth in the data. The graph here shows, it just gives two indicators: the amount of data in 2009 and the amount of data in 2020. And this graph stops at 2020. The current one would be much more than that. And see the way the growth of global data is happening. Can we move to the next slide, please? And we see that we are all swimming in a sea of data. It is huge. It is in abundance. And why is this happening? How come we're able to get so much data? This data generation happens because of certain factors. One of the main factors is digitization in every sphere of life. Every place we go, everything that we do gets digitized. Anything that is getting digitized, anything that is being computerized generates data. And that data gets captured somewhere, somehow. And the two more factors. One is availability and affordability of devices that generate it. Probably 10 years back, we had a limited set of people who had smartphones. Today, almost every second person you meet has a smartphone, generates data on the fly. Also, the bandwidth, the availability of communication channels. The earlier the bandwidth was very costly. With the growth, with the development happening, the infrastructure becomes much easier. While the infrastructure availability is higher, the cost of that infra as an end user customer is very less. So which gives affordability. So a common person is able to afford data on the fly, which was probably rare about a decade back. A decade back, we were not using too much of mobile data. It was all fixed lines and things like that. So we see that 90%, some figures I have here, 90% of today's data that is stored, it was generated in just 2 years. So I wouldn't even call this an exponential growth. It is much, much more than an exponential growth. And we also have data in terms of structured and unstructured data. We will, subsequent slides, we will talk a little bit about that. But most of the data today is unstructured or semi-structured. In the legacy systems all had relational databases. We were just capturing data in terms of fields, in terms of columns and rows, which was all very, very structured. But as we progress, things are moving from structured databases to non-structured ones. And incidentally, text and images forms the majority of the unstructured data today. Couple of indicators. Facebook generates 4 petabytes of data daily. Twitter generates 12 terabytes every day. If we look at Google, it conducts 3.5 billion searches daily. So we are, in effect, every activity that we are doing during the day, we are leaving a digital footprint. Every one of us is leaving a digital footprint. Again, it's a matter of debate. How much of that data is being used? How much of that is being analyzed? Firstly, the data that is generated, there are two chunks: usable and meaningful data. And a much bigger chunk is non-usable and non-meaningful data, which probably is not needed. But the meaningful data that is generated, how much of that? I think we're not even tapping 5% of that data for analysis. No. There's a huge scope for further investigation, further analytics into that. The graph below shows the growth of data. If we look at it, the world population is growing at a relatively much slower pace in this graph, whereas the number of connected devices, we had in 2010, we had 1.8 connected devices per person. Today, we are sitting at more than 4. So we have more than 4 connected devices per person. And if we look at our homes, especially with IoT happening, with devices which are getting controlled remotely, if I sit and count in my home, I would at least on my fingertips, I would be able to count at least about 10 to 15 devices which generate data. I mean, my CCTV, the CC surveillance camera that I use at the entrance of my home generates continuous data feeds. Again, which I may use in the future, but again, I overwrite it. Most of it is meaningful for me for a particular period. Beyond that period, it is not. I have the video feed for my entrance door. It is meaningful for me. I preserve it only for 15 days. Beyond that, maybe I don't need my last year's data until some incident happens. So the expectation is that by 2025, we will almost touch 10 connected devices per person on this earth. Can we go to the next slide, please? Okay. Now, again, this is a data matrix. On the one x-axis, I have structured versus unstructured data, and the vertical axis, I have the velocity. See, there are basically two things. Traditional data was generated in batches. It was generated in bunches, and it was obviously available for processing in terms of bunches. For example, if we look at a traditional warehouse or a traditional shop, what would happen is on a retail store, a person would generate invoices for the day, and these would get into a centralized system that would be uploaded at the end of the day, and then the processing would be done. The same thing you can correlate even in the banking industry. The branch would do their and I'm talking about maybe 15 years back, the branch would do their daily transactions. At the end of the day, there used to be a day end closing when they would upload their data into a centralized system. So there was a batch which was run, and then the overnight batch processing was done. Things today are moving more towards a real-time generation, real-time things, wherein data is available to you as and when it gets generated. We talked about a video surveillance feed. That is a real-time data available to me. For example, sitting here today, if I want to check the video feed for my home, right now it is a real-time data that's getting generated and that's available to me over the net. Now, similar things, again, if we look at video surveillance, video analytics, those are all unstructured data. Traditional data warehousing is a structured one. And going up to the real time, if we look at the data velocity side, real time data is mostly used in market analysis, credit analysis. It's used in these days, share markets use a lot of data analytics, which is real-time analysis. Similarly, fraud detection and fraud prevention is something which is done on a real time. Right? Yeah, we'll also talk about sentimental analysis in terms of social media, which sits in the center. So moving on. Now, again, the data that we have, it can be classified on various dimensions. Could be classified in terms of behavior, in terms of aging, the data type, the presentation, and things like that. And as most of us know, when we talk about data, we talk about qualitative and quantitative data. It could be numerical, it could be categorical. In fact, the various data types, and I don't want to get into the technicalities here, the various data types are nominal, ordinal, discrete, continuous. So qualitative data could be something like it's just a definition. I mean, how's the food? Good, bad. So whereas I could rate the food in a restaurant, if I had to give feedback, I could rate it on a numerical scale of 1 to 10. So 1 to 10 is an ordinal scale. Again, those values are discrete. It is not continuous. If I have to look at the speed of my car, if I want to capture the speed of my car every day, average speed, that would be a continuous figure. So there are various ways, and various data types behave in various different ways. So the way I would analyze a nominal data is different. The way I would analyze an ordinal or a continuous data would be totally different. Similarly, quantitative data gives us numerical metrics, whereas qualitative data just gives us the behavior of the data. It cannot give me a particular metric. Comparison is gross. It's not a very fine level of comparison. If I have to do a very extremely fine or granular level of comparison, we would need to resort to quantitative analysis. So similarly, again, data could be short-term, it could be long-term data. As I say short-term data, I gave the example of a video feed. My video feed for a daily analysis is my day's data, whereas on a long-term, if I'm preserving data for a year, it's my long-term data. A lot of metrics, for example, marketing data, there are certain parameters which are needed on a short term, but certain parameters on the long-term data, you sort of archive that data. Because if I need to probably have my previous data in order to do my forecast analysis for future. The data that we have is generally presented, and the end result of this whole thing is that I have to present this data. And the presentation of the data happens in terms of various methods. It could be a textual presentation, it could be tabular, it could be graphical. Most of the presentations today are visualizations. There are a lot of visualizations today, whereas tabular representation of data, tabular display of data is one of the most common methods, that's the most commonly used method that the data is. Now, before I proceed further, I would want to again get into a little bit more detail here, which is the essential and how does data touch us in our everyday lives. I'm sure that we all generate a lot of data. Our call records, you'll be surprised to know that our call records get generated today. If I go to my the telephone operator and they can actually pull out all of my call records. They have the data about each and every call I make. They have the data about each and every message that I send, that I receive. So these things can be, for example, in crime detection, they use call records as one of the essential tools that is used in crime detection and crime prevention. One of the first things today that the investigation agencies do is if there is a suspect, they would pick up his call records for the previous period, maybe previous 1 year or so, and then they would drill down. They would drill down into more frequently called numbers, odd time called numbers, and things like that. So you can do multiple. There are multiple ways of analyzing, slicing, and dicing of this data. You could, for example, if there's a suspect in a crime case, you could pick up his call record and see what are the numbers he calls frequently, and what are the numbers that he calls at odd hours. What is the duration of the calls? If there is a huge duration of call between me and one more person, that indicates that there's some level of familiarity between the two people. I cannot say that I don't know this person. He just called me once. If I have been making calls, if it is proved through data that I've been making calls to a person X for, let's say, 15 minutes or 20 minutes every day in the last 2 years, that establishes a familiarity between me and that person. Similarly, the financial health of a person today. My financial health can be checked by my credit card spending, my CIBIL score. One of the things that all of you know is something called CIBIL score. You must be all very conversant with CIBIL score. Now, CIBIL score today it's a simple indicator of a person's creditworthiness, of how he behaves financially. Similarly, what is happening today is our health records. If you guys are aware, there is a program being run called Ayushman Bharat, which as a subset of that program, as a subset of that project, they are capturing health records for each and every citizen. So if all my health records, if my health records get digitized, so anybody tomorrow, I have any medical issue, my health records are available for analysis, and they give an indication of my health. So, similarly, financial spends. Today, there's an anecdote. If you really want to know the character of a person, go and look at his credit card spendings. Any person's credit card spendings would definitely be a very, very strong indicator of his behavior. Similarly, and this is something which is actually being used. Similarly, the social media, for all of us, for those of us who are active on social media, the social media behavior gives an indication of your political leanings, your religious leanings, and this has been used. We have examples, though that's a very soft issue to touch. We have examples of political parties using data analytics for their profiling, for the profiling of voters, because and I'll talk about sentiment analysis a little bit later. That captures sentiment analysis does capture a lot of our behavior on social media. So, uh, so having said that, all of us understand that data today is becoming very, very essential. Data analytics is becoming very essential, and it is touching. The point is that I started with the paradigm. I started with the saying that it helps businesses in taking decisions, but it is as simple as helping us in controlling our own behavior. It helps us in identifying our daily behavior, controlling our spend patterns and things like that. For example, my credit card company sends me a credit card bill at the end of the month. They also send me an analysis of how am I spending. How much am I spending on grocery? What's the percentage spent on the grocery? What's the percentage spent on fuel? What's the percentage spent on electricity and things like that, which would be a good indicator for me if I have to control my expenses. Right? So, thank you. Can we move to the next slide? Now, this is a slightly technical slide, talks about data life cycle. What do we do with data? Now, we have this data available. There are multiple things that are done with this. One of the, we extract data from systems, multiple systems, where also there are times when it is replicated. Then we have to store this data, integrate multiple, and when we're talking about an analytics system, we have multiple sources of data, and we collate those sources then do the validation and processing of data, and then final output. So it's very simple. When we're talking about any data processing system, the input is the raw data coming from multiple systems. So multiple systems generate raw data that is brought into a system. It is collated, it is processed. Based on that processing, you generate some output, and that output is displayed. The display could be in terms of a presentation, which could be tabular, visual, graphical, whatever. So again, the sources of data are multiple. It could be relational data files, flat files, semi-structured files. It could be and as I mentioned, unstructured files. I also said streaming. Streaming is the video streams that come in, and this is used mostly. Streaming is used mostly for surveillance purposes. Now, the same data from multiple sources is collated together, extracted, stored somewhere, and then there's a transformation. Data transformation transforms raw data into a meaningful meaningful collation where it can be further helped. Basically, this processing is to convert from data into information. And again, from a technical perspective, there's a data warehouse where we store all this, and then there's a presentation as layer. So basically 3 layers: the sources, the storage layer, the transformation layer, and the presentation layer. And presentation, as I mentioned, is in terms of dashboards or reports and analytics. We also have the new concept that has come out is data as a service. So incidentally, before I move forward, I was mentioning that data is becoming very, very important. There are corporations which share. There are data banks, there are data sources. The data gets collated, and it is collated, and then it is available. There are some public sources where it is open. Data bricks are blocks of data which are segregated chunks. The term brick is used because it's a chunk of data which is similar in nature, and it's again, there are multiple concepts here, multiple terms here. We create Databricks gets into it's a chunk of data, and these are collated together, form data lakes, which again, data lake again is an isolated chunk of data, which gets into data marts and then data warehouse. And data warehouse is a huge collection of data, which is subdivided into data marts and things like that. So these are all concepts of data warehousing, but I would actually limit my thoughts here to analytics. So next slide, please. So we also have a term called data science. So data science and analytics, these are often used interchangeably, but the two terms are different. The difference is based on their scope. Data science is an umbrella terms. It has multiple chunks, including data analytics. For example, when we talk about Databricks or data warehouse is actually not a part of data analytics. Data warehouse is a component of data science, but that is separate than data analytics. Analytics is just analyzing that data, right? So analytics is a subset of data science and is focused more on analyzing the available data. Whereas data warehousing, which includes data marts, data lakes, data bricks, that is more about how data is collated and transformed. So, okay, now we're all I will talk about web analytics later on. Web analytics actually is same as data analytics. It's only that it is the analytics of data that gets generated from web. And why web analytics became very, very popular was because when people started doing digital marketing, one of the most sought about parameters was optimization engines, search optimization engines, where they wanted to see if I have a website, they wanted to see what is the number of hits I'm getting, how is my website performing in terms of customer, and also how's my website performing in terms of a search engine? Does it pick up my what's the search engine ranking of my this thing? So web analytics basically is properly about analytics pertaining to data generated through websites. Whereas when we talk about data analytics, it's a much broader concept. Data analytics primarily, maybe I'm talking about data which is generated at retail stores. Your Big Bazaar. When we go to Big Bazaar, when we go and do our purchasing there, all my data that is generated at a Big Bazaar checkout kiosk, checkout counter, that is customer data. All that gives me a lot of data which gets into data analytics. Whereas web analytics pertains only to the analytics of data that's generated on websites. Fine. So can we go to the next slide, please? Now, I think we skipped a slide. Priya, can you just check? Yeah. So now analytics, if we look at the picture at the bottom, we have data, we get in that data, we analyze it, we visualize, publish, and consume that data. And based on this, we take certain decisions. How do we take decisions? And what are the decisions that we take? We will talk about those in subsequent slides. But basically, qualitative analytics and quantitative analytics. Qualitative deals typically with metric-driven approach. Quantitative is metric-driven approach, whereas qualitative is not metric-driven approach. And it gives us insights about the data. Now, we process the data sets and draw some information, convert this raw data into information, which enables us to derive conclusions. Now, these conclusions also could be content specific. We might look at what if scenarios, what if analysis. I pick up this data and do a what if analysis. What if I do this? What if I do that? Change some parameters. So basically, it is analytics deals mostly about the discovery and interpretation of patterns within that data. And from those patterns, we derive relations and connections. So once I know that this is how my data behaves, this is the data generated, this is the trend analysis. All of us in a conventional mode, we all knew that we used to do trend analysis. So basically, if we do trend analysis, that gives us an idea of what is happening. And based on my current trends, I would also forecast what may happen in future. So my entire data processing talks about deriving patterns, relations, and connections. So we also use statistical analysis and technologies to find trends and solve these problems. So moving on, next slide. This is how data helps us to create business strategies. So I call it a data strategy slide, where I am here looking at any part of data that we look at, any part of data analytics that we look at. I have two parameters here. On my x-axis is a project. Any data project that I pick up, I have the project feasibility, and on the other side, I have the business impact. So the feasibility can range from low to high. Similarly, the business impact. So if we look at this, there is, and I've tried to map some of these here. The typical applications fall under mid feasibility but high value, high business impact. For example, the inventory management, the order management, and things like that. Whereas the analytics, the project feasibility is low because there's a lot of effort which goes into it. When I say feasibility, it is basically the project effort, the cost benefit. The project feasibility being low also because the tools that are available currently may not be so developed. So most of our analytics falls under the low project feasibility but high business impact. On the other hand, the high value, high business impact, and high feasibility is the management applications, which is basically the applications that are used in sales forecasting, lead generation, marketing generation, and things like that. These today are the quick wins, and everybody has been using them in the traditional mode. They're now switching from traditional to more of digitized mode. Earlier, if those of you who may have an exposure to sales management or marketing forecasts or marketing campaigns, opportunity or lead generation, we used to have this data which was captured manually or in subsystems and then collated. Today, it is done on the fly. So moving ahead, next slide. These are the 5 C's of data analysis and data analytics: communication, collaboration, critical thinking, curiosity, and creativity. Uh, it is basically critical thinking and creativity which lends a hand to data analytics. A lot of analytics work. You need a lot of critical thinking here. Obviously, communication and collaboration is there because when we look at analytics per se, it is large teams which work and they have to work in tandem with the business again. It is not in an organization wide. If we're looking at analytics in an organizational setup, from an organization wide setup, it is both the business and IT together which work on it. And within IT, it is supposed to be a separate data management team which works on this. So for example, if we were looking at analyzing the sales data, so it would be the sales team which has to collaborate. The IT team, the data management team has to collaborate with the sales team, with the business to understand their process, to understand the nature of the data that is generated. And incidentally, when the data gets any data that comes into a system has got to be cleansed in the first go, because raw data contains a lot of anomalies. We've seen that a lot of times raw data has problems. It needs to be cleaned. It needs to be ensured that your basic data is clean. Otherwise, unclean raw data leads to a lot of wrong inferences. It can lead to wrong decisions, which can be detrimental to the business. So data cleansing and data cleansing is something where the business and IT, the business and the data management team play a very collaborative role. I have been working on projects where, especially for the first level of data cleansing, I have to very closely interact with the business team because the nature of the data, the business process is owned by them. Since they own the process, they know the behavior of that data, they know the criticalities of the data, and we need to validate that before we further process it. So next slide, please. Now, these are the 3 pillars of data: people, process, and technology. This is what the data is: a bottom layer, it is a foundation, it is a people, processes, and technology which collate together and lead to analytics. So that is why today, when we say people, we talk about data scientists, we talk about data analysts, which is a subset of data scientists. And if you look at the top skills today, even in the IT domain, the top skills, data scientists happens to be a very high demand skill. And processes, of course, we're talking about process and technology here. And the technology basically has a very close alignment with 3 fundamentals: statistics, data science, and machine learning. Most of the analytics that we use in corporates and includes statistics per se. Some of the statistical functions, and it could start from very basic statistical functions to, for example, which we do in our everyday life, mean, mode, median things, to as complex as hypothesis theories and things like that. And machine learning has becoming a very close integral component of analytics now. Most of the advanced systems that we use today combines analytics and machine learning both to further process and give us and lead to AI, lead to AI systems, in fact. Okay. Next slide, please. Now, typical phases of an analytics project. The analytics life cycle starts with data collection. We collect data discovery, which is basically the domain study and the business needs. This is the domain study, and the data discovery is where we need to integrate very closely with the business, who will highlight on the nature of the data. Then the data is prepared, it is imported, and imported, converted into some definite format. As I mentioned, you could have multiple sources with various diverse formats, and these formats need to be collated into either a single format or an adaptable format. And then we do the cleaning, of course, and data cleansing is very, very important, because if your initial data is, there is a, in technology, in IT terms, there is a simple term of garbage in is garbage out. So I need to make sure that there is no garbage in the data that goes into the system. It's clean data. So because otherwise it'll lead to my output being tampered. So data analysis basically is comprises of data model designs, building data models, and then develop data sets, both for training and testing. And then we have the visualization and communication of results. And this is a continuous cycle. Right? Next slide, please. Now, these are the models, high-level models that I talked about earlier. Basically, there are four things in analytics. We have descriptive analytics, diagnostic, predictive, and prescriptive. Descriptive analytics is basically about what happened. Typical thing is your sales analytics, that in the traditional, and I'm trying to collate it with the traditional approach. Traditionally, what did we do? Traditionally, we used to have sales data. We do a description of, okay, North Zone has done well. It has met targets. South Zone has not met targets. They're short of targets by so much percentage, things like that. Diagnostic analysis is, why did it happen? If South Zone did not meet its targets, they were 20% behind the targets. So why did this? So it's basically diagnosing it. Then predictive is what will happen in future. So I have the past trends. Based on that, I will go to the future trends. And prescriptive is how can we make those trends change. So all these four things, as you must be aware, they lead from one to another. And basically, descriptive analytics and diagnostics talks about previous things, talks about past, talks about the captured data. Predictive and prescriptive is future data. It talks about the future. And if we look at the value chain, it goes up along that. So and these are used in every sphere of life. I can give everyday examples, starting from a retail store to a hospital to a medical diagnostics medical store. So in a retail store, you analyze your sales. It could be a product mix, things like that. So if I'm running a big bazaar and I have data for the past 1 year or 2 years, I could probably I could probably analyze and find out about how I what happened and how did it happen, why did it happen. So whereas I can predict future, I can predict all the future, especially in retail stores. Predictive analytics is very, very important, because based on trends, they do the future stocking for the next season. And prescriptive is again for customer integration. How do I go with customers? How do I increase my customers? Data replication is not a part of for the previous question, and I'm taking questions side by side wherever I'm able to. So data replication is more of a data science. It's a data management part. It is not a part of data analytics. Replication and ingestion is basically a part of data warehousing. So analytics is a further one step ahead, right? Okay, so next slide, please. So the approach today mostly is predictive, and this is the focus that is happening today in most of the data analytics parts, is predictive analysis, data mining, data visualization, real-time business intelligence, and web intelligence. Predictive analysis, as I mentioned, is prediction for future based on the data. We do a lot of future predictions used in almost all industries, and retail industry is the best example of this. Data mining is, I have captured data, I have huge data, I have a huge data warehouse, and what we do is, based on that data available in the data warehouse, I try to find out patterns. I try to find out why did this happen, what will happen, and this helps I have case studies. Those of you who are interested, you can connect with me. I have case studies for data mining in the automobile industry. And automobile industry, it goes through ups and downs. There have been multiple cycles where it's gone through downsides and then gone up again. And data mining, we have classical examples of data mining in automobile industry. Visualization, we have a lot of visualization tools. We'll talk about these later. And similarly, real-time business intelligence on the fly, I need to generate. And real-time business intelligence is something which is used. Share markets is one of the best examples of a real-time business intelligence, analyzing share prices on the fly. And web intelligence is something closely related to what I mentioned earlier as web analytics. So based on the web patterns, web behaviors, we derive this. Next slide, please. These are the typical tools. I will not spend much time on this slide because I know we are also running short of time. But these are the tools that are used for data analytics. R and Python is basically a language which is used specifically. Hadoop is used for big data. And again, these are not only these are not only from a perspective of uh, data analytics. These are also from a perspective of overall data science. The visualization tools here are Tableau. I have also listed MS Excel here. Most of us use Excel, and to be very honest, I think Excel is a very, very good analytical tool. Though we don't consider it's a very preliminary tool, but I would make a bold statement that all of us who use Excel use only about 10 to 20% of the powers that Excel has. Excel has very, very advanced features which most of us do not use. From a visualization perspective, Tableau and Power BI are very popular. SAS again it helps us in statistical analytics. Next slide, please. Now, this is about the applications. I would just talk about, and this is just an example. These are some of the cases that I wanted to talk about. One of the applications that's very popular where you use data analytics is fraud detection. Credit card companies, they use it for their customer profiling. They create a customer profile and then create customer attributes based on spending patterns. Then they also have they also create transaction classes based on past transactions. And these models are used to detect frauds. For example, if I am a credit card customer with a particular credit card company for the last 10 years, they already know my spending pattern. Suddenly, if they find a spike in my spending, they find there's a huge spending or there's I never, for example, I never shop for jewelry on my credit card. And one fine day, if I just go to a jewelry shop and suddenly there's a transaction of 1 lakh rupees on my card, and this is again a this is a real scenario that I'm telling you. This has happened with me in the past. I get a call from a bank saying that there is a swipe of 1 lakh rupees in a jewelry shop. Have you done it? Because they are suspecting a fraud because I've never behaved like this. This is real-time fraud detection analytics, and this is a this is highly successful in being used by credit card companies today. From a sales perspective, marketing perspective, customer churn is something where you use data analytics. Again, here customer transactions are collated based on the customer transactions, based on their frequency of churn means losing a customer. Churn is I have 20,000 customers and suddenly my customer base is going down to 18,000. And I find I'm losing 2,000 customers. Why? What happened? So, and the example that I gave here basically is I'm talking about this typical example that I had in mind when I made this slide was the telecom industry. I was talking about mobile phone customers and related to that. So mobile phone customers have a call pattern, right? I think we've lost the slide. I'll keep on continuing till the slide is displayed. I'll continue talking. So similarly, call patterns. Mobile phone companies, they recognize my call patterns. So based on call patterns, they would offer me loyalty coupons, um, loyalty programs and things like that. So in order to prevent from losing your customers, to reduce your customer churn, data analytics is the best possible tool today that is being used by corporations, by that businesses. Similarly, we have also the clustering. For example, clustering means, and I'm talking about document management here, typically used in knowledge processing. KPOs and medical transcription. KPO is related to medical transcriptions, litigation industry, legal transcriptions. What happens is you identify frequently occurring terms in the documents. Based on frequency of those terms happening, you measure the similarity. So analytics can be used in comparing two documents and identifying the similarity of those documents. So once you know documents are similar, you can then sort of cluster them into similar documents. So these clusters can then relate. I have a new document that is coming in. I will relate it to my existing clusters and put it in a particular cluster. So document management is one of the main functions, applications of analytics. So Shalini, I think we have lost the slides.
Yeah, I think there's a sudden power failure, Priya.
No problem. I'll continue. So
Yeah.
I'll move to the next. We can separately share the slides if anybody wants this later. And the next analysis. Sorry. Okay.
Oh, great. Nandana has got it
Can we
now.
go to the next slide, please? Okay. The next application that I have was about this is funnel analysis, which is used on this example. Basically, is from a e-shopping site. Now, what we do here is, if you can go, can you do a full screen here? This is typically, I have people coming on my website. I have a e-shopping site where I put my product for sale. People come and shop on this site, but I realize that there are a lot of customers who are dropping out. So I do a sort of again, this is web analytics here. What happens is I capture data and then analyze these into phases. So I have, in a typical setup here, I have 4 phases. People come onto the home page. And this is again real data which was captured. 289 people came and visited my home page, but only 239 people signed up. And once they viewed the sign up page, and once they signed up, it was 105 people, out of which only 34 people purchased. So I see that I am losing from my conversion from viewing homepage to viewing sign up page is 83.3%. Similarly, the conversion ratio from viewing a sign up page to actually signing up is only 44%. And this particular example, when we actually checked up, we found out that the signing up page, the page where people were signing up, where the churn, where the conversion rate was only 44%, the page was improvised and this percentage went up. We realized that there were too many fields. While signing up, people found there was too much information and it was not user friendly, so people were dropping midway.
Excuse me, sir. So this is sorry to interrupt you. So this is basically a part of web analytics, I believe.
Yes. This is typical web analytics. This is a typical web analytics example. So in this particular example, the diagnostics that we did is we found out that we were losing a lot of people at this 44% stage. So to convert them, to improve them, we did improve the sign up page. So the sign up page was reformed. It was made into much user friendly page, lesser information, essential information. Also, some of the some fields were pre-populated, which led to an improvement there. The purchase page, of course, if you look up here, the sign up to purchase is 32%. Now that is something which was related, which if you actually see, that is related with the purchase process, the process of how good or bad is my product offering. So in order to improve this, the the recommendations that we gave the client was that you need to improve your products. Probably people are not buying your products. They are signing up but not buying. That means they're not liking your products. Improve the products, improve the pricing, and also make it user-friendly. Right? So we can go to the next slide. A very important, can you move to the next slide, please? A very important application is sentiment analysis. And sentiment analysis, no, the previous one, please. Sentiment analysis is also called opinion mining. Now, what happens here is it is used essentially on social media data that we pick up from social media, data that we pick up from blogs. It is basically used to analyze the behavior, individual behaviors. And we use natural language processing, we use text analysis and linguistics for this. So you have the source data. From the source data, some subjective information is captured. And then again, identification of frequently occurring terms. The best example here is Twitter sentiment. So what we can do is from Twitter hashtags, you pick up hashtags. From hashtags, you compare tweets and identify it as a positive or a negative trend based on positivity or negativity. And then you can calculate sentiment score. So if we are talking about, let's say there is a movie, if Jawan is a movie which got recently released yesterday, so I would go and do a comparison on Twitter. I would pick up a subset of data from Twitter and compare how many tweets are talking about positive for Jawan, how many are doing negative for Jawan. So accordingly compare the two and then declare, okay, for Jawan on sentiment analysis says that there's a positive score or there's a negative score. On the other hand, as an individual, if somebody has access to my Twitter data, they can pick up my entire Twitter data for past 1 year and see the kind of tweets I'm making. They can put, and I'm simply talking about pro something, pro A or pro B. So if we're talking about, let's say, if we're talking about, I don't know, if you're talking about football, there are two teams in football, Team A and Team B. So if you and I'm a football fan and I frequently tweet about football. So if you pick up my tweets for the last 1 year, you can see my pros, my positive and negative tweets about Team A, my positive and negative teams about Team B, and then you can derive from those sentiment scores, you can derive whether I am a pro A or a pro B. Now, this is the exact stepping stone for analysis that is done for political opinions. I would not delve further into that. I would leave it at this point because opinion mining is an essential tool that is used in political campaigns. Next slide, please. Now, this is a case study. We are running short of time. I wouldn't want to spend more time on this, but most of us use Netflix. Netflix is a classical case of business revival. I would use the word revival, business revival through data analytics. A few years back, Netflix actually started as a video rental agency. From a video rental agency, they went into a DVD rental agency, and it was actually not doing very well when the whole thing was revamped around 2000, post 2009, the whole thing was revamped. And Netflix uses recommendation engines. They have ranking algorithms where they modified their algorithms, and based on algorithms, they decide upon the kind of movies they want to keep, the kind of shows they want to show. And again, this is being followed by most of the OTT channels today. And Netflix does a lot of analytics based on the data parameters. Data parameters, day, week, season, and periods. For example, during the FIFA season, they would bring in more shows related to football. One of the essential success stories of Netflix is House of Cards. House of Cards actually turned around Netflix. It did something like what KBC did to Mr. Bachchan. KBC turned Mr. Bachchan's whole story around. Similarly, House of Cards did it for Netflix. Based on analytics, Netflix at that point of time was just doing normal shows. When they realized that they saw various parameters, from various parameters they arrived at something like BBC production. They looked at original BBC productions, and they looked at Kevin Spacey as movie and director as David Fincher. Based on these parameters, Netflix remade a BBC drama. They did a remake of original House of Cards with Kevin Spacey and David Fincher, and the serial landed up with 33 award nominations. The other thing that it did was they moved from shorter episodes, they moved from longer episodes to shorter episodes and binge watching. The pattern, behavior pattern, viewer pattern got changed, and it was looked at that the viewer pattern is gradually changing. For my generation, we belong to Doordarshan, where we used to see Hamlo, or Bunyad, where a serial, the next episode of the serial would come next week. So we had to wait 1 week to understand what will happen in the next episode. So today I have those available on the platform where I do a binge watching, seven episodes. The whole thing is done in a night, and that is what the public likes. The advantage that Netflix derived was from 2013 to 2023, within 10 years, the subscriber base moved from 33 million to 238 million. The market value, 5.7 billion to 168 billion. A lot of analytics today is being used in the show industry. Most of the movies, in fact, today, the marketing of the movies is done with research based on analytics. So I will stop here. Our next slide is a question mark. If you go to the next slide, let's stop here and we'll move over to questions. During this chat, there were certain questions which I have answered as we went along, but if there are any further questions, I would be happy to take those right now.
This was a really excellent talk. Anybody, any questions? Please feel free to ask.
I have a question. Now, this is a real-time question.
Yeah.
So now, right now, when we talk to our clients, they already have past data, right? And
Right.
they would have already done their, predictive analysis.
Right.
But now, with data analysis being on the forefront, when we are getting situations where their forecast of what would happen and actually what took place does not match. And even when using data analytic tools, or even if you're using ML, we're not able to resolve what was the reason for difference. And the difference is like 50% and above. What are your ideas that how could we apply creative thinking in data analysis? My thought is maybe it is something to do with creative thinking.
You are very much right. If I get this question right, you are talking about the performance gaps in the past data, right?
Yeah, because I'll tell you, there was a forecast that was given that they will hit numbers of say 100. And the next year, when they were checking, the numbers hit were 150. Okay, for one place. Another place it was 100, another place it was 50. But when they're using tools to predict the next year's data, they're again predicting numbers, and still there is a spike in the actual figures, sales figures.
So it'll all depend upon the it'll all depend upon creative thinking. And also there are multiple parameters. It's not only one parameter. It again depends upon multiple parameters, multiple factors. Sometimes there is something called, and you will need to do a root cause analysis on this, and it's all learning. See, your forecast versus actual will never be absolutely correct, but that gap gets, the more and more tools you apply, the gap gets reduced. I have done a lot of collation on COVID data. During COVID period, we used to actually do forecasting also, and it was off the mark. But then there were other factors which were, and again, there are factors which are controllable and non-controllable. There are certain factors which are non-controllable. For example, when we used to do analysis on COVID data, there was a human element that could never be controlled. See, the scientific theories are R0. I'll not get into that detail, but scientifically, we would predict something. But that was fine. The virus behavior, the medical behavior is okay there. But then there's certain factors were there about people behavior, which was your distancing, wearing masks and all that, or getting into crowded places. That's something nobody could control. And we actually saw, numbers going up, the infection going up during festival seasons and things like that, which was directly related with people behavior, which could not even be controlled by the government.
Correct.
So those are non-controllable factors, and one will always encounter those. For example, even in sales, if you're talking about a particular product, you will always come across certain factors which you would never have imagined, but out of the box factors which will come and impact people's opinion about that product at that particular point of time.
Thank you.
Thank you. I think if anybody else has any question, please ask us. Otherwise, we will start the closing of the event.
There is a feedback that I have to give. I think you rightly said that only 20% of the potential that is there with Excel is utilized. If we use data analytic tools and work from Excel and have it integrated into the systems that we use, I'm sure there is a lot that we can do with just one product. This is an untapped reservoir, right? Isn't it?
No, I'll give you my personal example. My colleagues had data. We used to use, for this COVID data, we used R and all that. But I personally have been collating COVID data from 14th March 20 till date. I have about 3 years of data with me. I publish data trends every day on Twitter, and incidentally, all of this is in Excel. 100% Excel. Despite my access to other tools, I do have visualization tools also, but I deliberately did not use that. But everything is done on Excel with obviously advanced features and macros.
Absolutely.
So we need to tap the available resources, basically.
It's a cost-effective tool also.
Yeah.
So there's a very good question here. Somebody's asked, hi sir, what certifications or courses you would suggest for a woman on career break, maybe connected with this field?
I think the certification and courses, there are multiple courses. It would depend upon particular interest. And these days, one of the good things these days is there are a lot of online courses available through Coursera, Udemy, and others. You can choose your own course. And good thing is that a lot of courses are there where the courseware comes from reputed universities. I mean, I've actually done certain courses where the course, not even for certification, the certification may cost you. You can even do a free course where the courseware is from university like Harvard or something. And these are very, very interesting content. So I would actually, just for a start, if you want, Coursera has a lot of courses on basic data science. So one could start from that and then go on.
Yeah, and I think even Google has got something.
Yeah.
On this. Great. Now, Nandana, you wanted to share your thoughts. You've been waiting for a long time. So before Nandana comes, I want to really thank you, Sunil Bhattalji, because this has been really so interesting. We don't want it to stop, but we will have to put an end to the proceedings. But before we do that, thank you so much. And Nandana, please please feel free to share your thoughts, what you wanted to share with us.
Thank you, Shalini. Well, ladies and gentlemen, that was a wonderful session, knowledge sharing based session today on data analytics and digital transformation. I'm Nandana Bhattacharya. I volunteer in digital creatives and data analytics with WICCI. Data analytics and digital transformation are the dynamic duo revolutionizing modern business by unlocking the potential of data for innovation and strategic growth. For business, it helps in number one, informed decision making, number two, to have a customer centric approach, number three, gives a competitive advantage by utilizing data analytics to stay ahead in rapidly evolving business landscapes. Number four, to create innovative strategies, data insights drive innovation, helping business develop products and services aligned with market needs and trends. For corporate employees, it helps in career advancement, enhanced productivity, skill development. So learning data analytics cultivates a valuable skill set, enhancing professional adaptability and marketability. Number four, improve performance by incorporating data analytics into workflow can streamline processes, resulting in more efficient and effective job performance. Number three, advantages of data analytics for job seekers: increased employability, diverse career paths. Proficiency in data analytics opens doors to diverse job opportunities across various industries, expanding career choices. Competitive salaries. Jobs in data analytics often offer attractive remuneration due to high demand for these specialized skills. Number four, future ready skill set. So that's all for now, and rest to you, Shalini.
We got the idea that you wanted to share. Of course, I think data analytics is really very important. And I personally feel that, we can use it from our personal life as well as for professional lives too. So I think with this, Priya, if you want to add something, otherwise we'll put an end to the proceedings for tonight.
I think I've already added the points that I have.
Perfect. So thank you so much, Sunil Vatalji. This is really very enlightening. And now I feel inclined to take up a course on, the data analyst, course from somewhere. I'm going to find it. And so thank you so much for a very enlightening talk. And I think this has been a very informative session. So thank you everybody who has attended. And so that's it from our side for tonight. Thank you. And good evening and good night.
Thanks. Yeah. Thank you.